Hello and welcome to Webcast Wednesday. Today we're going to be looking at 3D scanning. I will be your host, James Donnelly, and I'm an Information Technology Specialist at Southern Regional College. I have over 20 years of hands-on experience in engineering, covering various aspects of engineering, from general engineering all the way through to heavy industrial engineering. Through my time in engineering, I've developed many products. So, as I said, we're looking at 3D scanning. So there's various definitions of 3D scanning. I see 3D scanning as scanning a real world object and bringing it into the 3D environment so you can play about with it in CAD systems. There is various types of 3D scanners available. The one that I'll be looking at today is called structural light. Okay, so structural light 3D scanning technology uses structural light that projects line patterns onto the real world object. This in turn is taken up by the scanner. It reads the lines and creates the three-dimensional image from it. So we purchased a PIG 3D printer, or scanner, sorry. The reason why it was affordable, it offers professional grade results. It's very easy to use, it's light, it's portable, and our demonstration today will show how we actually use it. Okay, we're going to do a quick demonstration as such on how to scan a real world object in 3D. So we're going to use PIG 3's own software itself. And as you can see here, we have to say we want to do a new scan. In their own software, there's a number of steps you have to go to select the object you're doing. So it's pretty simple. Tiny, small, medium and large. It gives you, if you hover over the actual wording, it gives you a description of what they mean by small, tiny and medium. Because our part is small-ish, tiny, we're going to go tiny for today. We're going to go very fine, and we're going to go an expressed output. We're not going to take colours today because I don't want to, because I want to keep the processing power good. So we're going to do a very basic scan here of the object. So it helps if you've got a screen beside you like I have set up here. I have certain controls in the handheld device that I can zoom in and zoom out. It's important as well to have the correct distance from the handheld scanner to the object. If you're too close, it doesn't like it. If you're too far, it doesn't like it. But you're lucky enough, the scanner will actually give you feedback in the controller here to let you know that the scanner to let you know that you're too close or too far. So I'm using a very basic turntable that one of my colleagues got for me. It allows me to rotate the object around very quickly, and I suppose because this is a demonstration, we don't really need to put as much detail into this as we should. So as this is a demonstration, we're just going to quickly go over a few areas of it. As you can see, we're starting to get a very good image already of the object we're scanning. Now, for higher detail, I can actually zoom in and spin it about. Now, you've probably noticed there's a number of white targets on the actual turntable and on the item. These targets are help for the software and the scanner to actually understand the object's location. I'm just going to turn this around. I want to get a lot of detail in this if I can. Because what I'm going to try to do is I'm going to actually try to turn this part upside down and merge two scans together. Okay, I suppose the next stage is to get the part out of the scan. So we're going to go into the next step in the process of the PIL 3 software. So in this step is the cleaning process, where we use different type of tools to clean the part. So at this stage we're using a plane to get rid of everything on one side of the plane. As you can see there, it's highlighted in red. I go to continue, and as you can see very rapidly, half the information's gone that we don't need. There's many commands within the cleaning program. We're just going to go to select the items we want to keep. So it's intelligent enough, the software, to understand that is all one part. And what we can do is we can get rid of everything and keep that one part. So it's fairly quickly it can do that. So this allows us to take this first scan, and what we can do next is we take the next step or add the next scan. So it takes a few seconds for the software to actually initiate a new scan. So what we'll try to do in this case is turn the object upside down to get the part of the scan that we couldn't see originally. As you can see there, it's the same process as we had the first time, where we're traveling over the part, trying to pick up as much detail as we can. As you can see, it's tracking all the targets. That's them wee white circles. And as you see on the screen, the green lanes, are the scan lanes, and that's the process we're using. And it seems to be picking up and getting good readings there. So that should translate to a good scan at the end of the process. If you weren't getting good readings like that, you have to change your settings at the start. You can go in at any stage and change your settings. From choosing a tiny object to a medium object to a large object. Sometimes you just have to spend a bit of time playing about with your settings to understand exactly what suits your own requirements. Again, I've got the wee white circles. Then white circles are very important to give us a location in real time of the object. I have got circles going on the plan view of the turntable and around the turntable. And I've got a wee square object to the right hand side, as you see on the screen, with yellow or wee white circles on it. That's all to allow me to go at different angles and to get the more clear scan. If I didn't have them, I would find it very difficult to actually get very good readings, because the scanner probably would lose, its location of the object. As you can see at this stage, I'm in underneath the part, trying to get as much detail as possible. And you can see, there's a wee bit of having to, reorientate the part again. Again, since we're doing it as a demonstration, we're not spending much time. We're probably going very quickly here. But at the same time, we seem to be getting the results we wish to get. As you can see, it's picking up the turntable, more detail there. Then wee white dots will be used for the next process. Well, the next process will be cleaning again, but the process after that of merging. The merging will be a lot more simpler because there's a lot of like dots on it. They'll be able to automatically reorientate itself without very little user input.
And as you can see, after we cleaned the part down, we're in the next section of the process, and that's called merging or merge, where the program was able to merge the two scans together seamlessly, as you can see in front of us. As you can see, the process isn't finished yet. It is a wee bit grainy, but that's because there's other processes that we have to go through. So again, you do need a fairly good computer to process the information, as this laptop is powerful enough. It's still taking a wee bit of power to actually bring it to the next stage. So as you can see here, it's already been able to give itself understand an axis, the X and Y, and it does that there itself. Now you can, of course, change your X and Y's and your axis, no problem. I'm happy enough for that. It aligns everything perfectly there. So next step would be the improve section, where you can see there, the scan looks a lot more like real time, and we get a better image. And really, at this stage, if you weren't happy with some of the scan, or if there was detail there that wasn't correct, of course, what you can do is you can rescan and add it in.
Well, that's the end of our webcast on 3D scanning. Thank you very much for watching and tune in again. Bye.